Okay, we have a MacBook Pro. It says dead. So what that means is no power. It's an A1502, 13 inches. As usual, the first thing we want to do is we want to take out the back cover before we plug our charger to the device. We need to have an idea what is happening inside the device. Visual inspection, very important. You don't want to unknowingly. So we try to make this a practice, especially if the device is coming in for no power. Before we plug in our charger, we first take the back cover out, get to see what the inside looks like before we connect charger to it. Okay, so uh, you see the shield here is missing. Most likely has been in for a repair. There's supposed to be a screw here that's missing. We have another screw there missing. This is a 2015. So the A1502s you have started from 2013, 2014, 2015. So there are three. There are three of the A1502 models: 2013, and 2014, and 2015. So the 2013 and 2014 can be interchanged. You can use the board. Everything for 2013 will work on the 2014. However, that's not the case with the 2015. The 2015, one of the standout difference for 2015 is the trackpad, and which is the 2015 uses the haptic feedback design, the haptic engine, and then you have the trackpad cable will go over the battery. The 2013 and 2014, the trackpad cable will go underneath the battery and not over the battery. So this is one of the that this is one of the example in terms of the chassis for you to tell the difference between a 2013 and a 2014, 2015. Okay, we see some screws are missing, including the screw here, and it's a low power. So what we want to do, it doesn't seem like a liquid damage device. So we are going to disconnect our battery and then connect our charger, and then we take it off from there. Okay, we have indication, we have a LED on our charger. And then, by the way, so with the 2015s, the fan is not going to spin right away. So if this was a 2013, 2014 MacBook A1502, when the device is in SO state or when the device powers on, the fan will start from start to finish. The fan will go on. But with the 2015, the fan would only come on when the CPU it's really hot. That's when the fan comes on. So this the device, they say it's not powering on, but I'm just stating that even though it's a low power, should it start to power on, the fan may not start immediately. So that is that. So check. Let's see what we have. Let's check our basic rails. This board, it's going to be 80-29 4924 4924. Let's just confirm that 4924, yeah, 80-4924. That is our 2015 board. 4924, yes, 4924. Let's search that. It doesn't seem to have it open. 80-4924. Yes, that's our board number. Let's try to move it a little bit closer. So that's the board number. That's the board view. Now let's open up the schematic. So same thing, 80-4924. 4924. Okay, and there you go. So that's the schematic. So the first thing we want to do is we want to say so. Let us go through the sequence of it. So it's a no power. What we want to do after we've opened up our schematic, the next thing we want to do is we want to go to the page that lists all the power rails that is expected to be present on that machine to have a functioning machine. So if we go to page one of our schematic, we should be able to see where it says. So one, two, three. We're looking for where it is power aliases. Power aliases. Mm, okay. It's power sensors. No, that's not what we're looking for. Power effects, and that's not. Yeah, power aliases. So this is what you're looking for. So we need to go to page 68. So let us now, let's go to page 68. 68, that is where we want to go to. Now on page 68, this will give us a list of all the power rails which are going to be the working condition for our machine. So at the top of it, you see where it says G3H. So that says that means always present rails. Those are the ones that are going to be referred to as what? G3H. Now, the first thing we want to check is we want to see if we have PP bus. So if you look at this, if you look at this, it says at the beginning, it says 54, 53, and 71. So basically, so this is going to be present on this on page 54, on page 53. But that's not why. So first thing we want to do is we want to see if we have PP bus underscore G3. Now PP bus is going to be equal to all of this. So if you have this rail, then you will be having all of this rail. So what we want to do is we want to copy this rail and then paste it on our we paste that rail, or we can just search for it. Let's search for PP bus first. Let's start from PP bus. Even though PP bus is not the first rail, because we need to have PPV in, which is basically your charger DC in. So we're connecting charger to the device. Let's just check the trackpad. Okay, we don't have power. Yeah, okay, fine. I was checking to see if we have trackpad feedback. So PP button that's got G3 out is not the first rail because you need PPV in, which is the PPDC in voltage, which is what will come from the charger before you will have PP bus being generated. But it's so happy. So I'm just saying. So it's not like PP bus is the first rail to measure. So here it says PP bus is 8.6. That's not correct. 8.6 is for MacBook Air and not a MacBook Pro. You are looking at 12 point something volt for MacBook Pro and not 8.6 for a MacBook Pro. So what you want to do is you want to go to the board view which we had opened earlier to now search for this because we want to see if it is present. So we want to search for PP bus underscore G3 hot. This is the board view. So let's go to search and then we type pp boss underscore g3h and then we click on it. It will show us all of the places that signal is present on the board. So we want to, because we yet to take the board out, okay, actually let's just take the board out so that it makes things easier. So let's take the board out. We see some of the screws are missing. That may suggest that the device has been there's been a previous repair attempt on it, and sometimes it may also suggest that from the last repair, the screws were not completely put back from wherever the device has been before for repair. Okay, so we have very minimal screws because most of the screws were not put back, and we also have some missing shields. Let's quickly take our board out to get an idea what state our board is in, and then we take it up from there. So generally that is how repair works. You define what state the board is in, and then you build up from there, and then you obviously identify what needs to be done, and then yeah. So our board is out. Let's put the shell on one side. Okay, so the first thing we said we want to do, we have already searched for PP bus. Let's connect our charger and see where PP bus shows up on the board. and then we measure to see what we have. Now, if we can get PP bus, we can measure for PP bus here at R705, and that is going to be this guy here. We can measure for PP bus there. So let us. Are you able to see the multimeter? Okay, let's see what we have on our PP bus. PP bus is zero. Let's just check that again. PP bus is zero. Let's just confirm that our multimeter is working. Okay, no, sorry. So we press on hold. That's why. Okay, now let's check again. So as you guys can see, PP bus is 8.6. PP bus is 8.6. That's fine. So that is, like I said, it's not 8. Sorry, PP bus is 12.6, not 8.6. I'm actually following up the what I saw in the schematic. So PV bus is 12.6, not 8.6. So we have confirmed that PV bus is present. Now that is done. We move on to the next. Now PPV in underscore S5, that is definitely going to be present, but let's just, for the sake of it, let's just also copy that and paste it on our board view to confirm that that is also present. Uh, hmm, hmm. PP was underscore S5 HS something. Okay, let's just search that. So PP was underscore S5. Okay, that's it. Let's see if that is present. We suppose that is going to be present. We can measure that at Q7430 as well as C7431. That's going to be these two guys here. Uh, let's see. Okay, so this gaps here we can measure here, and we see that that is present. Let's just confirm that. Yeah, that's present. Let's move on to the next. So we don't have to worry about this. That's fine. This is also going to be present. This is going to be present. That's going to be present. This is going to be present. PP. So this is the primary voltage line, which is DC in. So PP 18V5 underscore DC in underscore ISO. So that is definitely present, because if that was not present, PP bus will not be generated. If that was not present, we will not have charger indication. So that is definitely present, but just for the sake of it, we can still measure that, just so that you guys can see that that is indeed present. So it's going to be PPDC in. So let's just search for that real quick. So it's PPDC in. Okay, yeah, this is the rail here, and we can measure that here at R7020. R720 is going to be uh, this guy here, this one here. So let's see. So you guys can see we have 16.6, 16.6, 16 points. So that is fine. I mean, we really no worrying about that, because if that was not present, we would not have PP boards and we would not have PP3 before. So this is fine. That's fine. Then this is also fine, because PP3 before 2 is required for the one wire circuit, which is basically how you get your LED on the charger. If that was not present, we will not have the charger. We will not have LED on our charger. But just so that you guys can confirm that it's present, let us also measure that. Let us also check that out. So it's going to be PP3V4, PP3V42, and so that is going to be 3.3 volt. We can check on the other side of the board. Let's check this in, use this inductor to confirm L7095, which is going to be this guy here. So let's see that. And as you guys can see, 3.4 volt is present. So the next thing we want to do is we want to go to, so that is confirmed. The next thing we want to do is we want to check our clock signal. So we want to check PPV RTC G3. So that is going to be our clock signal. We want to see if that it's we want to see if that is present. So PPV RTC underscore G3 hot. Let's see if that is present. RTC underscore G3 hot. So it's so that we can measure at U1900, which is the clock generation IC. So U1900 is this guy here, and okay, let's see. Clock. Do we have? Okay. So we can measure PPV. We can measure the clock on the other side of the cap. So let's see that. That is the clock signal is present, which is 3.3. That is fine. Now there's something that we usually would do. So before we actually start to make measurements at individual at different sections of level of the board, let us do a visual inspection first and see if anything stands out, and then we'll continue. So let's just do a visual inspection. Usually I would do that before I even start making measurements. So let's do a visual inspection to see if anything stands out. The board is fairly clean. Um, so let's see if anything stands out. Uh, we have a bit of liquid trace here. We will check what that is. Now, before we continue on our power search line, so we want to see if we have a short across the board. We will just make a random measurements across the board to see if we have a short. And then there is also something I saw across by the clock chip. I'm also going to check that. Okay, that is a short 0. So let's see what is that. We're not supposed to get bips on both sides, but let's see what that cap is supposed to do. So that cap that we heard, that beep that we hear, it's on this cap, and that cap it's and that it's the SO signal. That is PP3V3 underscore SO. So we're getting a beep. That means we have a short to ground. So it means a component on the line of one of the components on the line of PP3V3 underscore SO, it's short into ground, and that is definitely preventing the device from starting. So we are going to not continue on our line of so usually the way I go about this is this. So first thing I do is I obviously take the board out. After the board is out, I do a visual inspection. If nothing stands out, the next thing I'll do is a measure for a short. If I don't find the short, then I'll now continue on going over the power rails. So we had to take a different route on this one, which is to go over the power rails first. But then we had to. So it's always best you kind of take it the other way, which is do a visual inspection first. Obviously, you check on your basic power rails. And then after the visual inspection is done, you want to check for a short before you now continue to check for the existing power rails. Okay, now for this particular board, we can see that we have a short on our PP3V3 underscore SO line. I'm just going to get another board to give you guys an idea of what we're talking about. Okay, so this is another board, and that cap, this cap here, C1212, is this. So I will show you guys. So my black probe is on ground, and then my red probe, this is the cap here. We can see that it's supposed to be OL. But on this board here, when we measure that, we are getting a beep. So that tells us that we have a short on that line. The short may not necessarily be on this cap here, but we have a short on that line. So the next thing we want to do now is we want to do a visual inspection to see what is connected to that line. Especially, we will start by putting our focus on capacitors to see what is on that line that may potentially have basically failed. So okay, so if we come to this section of the board here, we have a bit of corrosion here. I mentioned we had a bit of corrosion that side. Now let's see on that side. Do we have? Let's see. So this is the side here. This side. Let's see if we have any. Let's see if we have a component that is connected to the SO line there. So we're talking about. So it's going to be this section here. These are the three caps. So these three caps are going to be these three caps here, and U1790. This is going to be U1790. So now what we want to do, it's basically we want to see if we have. So that is R2995. So R2995 is going to be this guy here. Now we want to see what is here, what is there. This cap here, this resistor here, and what about this cap? What line is that cap in? Okay, that cap doesn't seem to be in an SO PP3V3 SO line. So if we see what we are seeing, it's what we want to do is we want to do a vision inspection and see if any cap, especially, it's not looking the way it should. Any cap that is discolored or having a bit of oxidation, corrosion, which might suggest that it has failed. So that is what we want to look out for. We are yet to see anything. And then the outside of the board. Just confirm that we have a short on. So there. So that's what we have a short. So now, since we cannot find anything that stands out, let's just do a visual inspection on where we see that line is connected. So here, which is going to be here, we don't see anything that stands out here. And then the next one we want to check out, it's U3400. We don't see anything that stands out at U3400. Okay, so let's see. What about you? Q2945. We don't see anything that stands out, which is this guy here. We don't see anything that stands out. Let's Let's see. We have, let's see, what line is this? Okay, so let's see that. That seemed to also be. So, let's see. Okay, no. So that doesn't look to have there doesn't to be an issue there. And then let's see what's here. That's a resistor. Hmm. Okay. Let's see. Okay, on the other side, we have more of that. Uh, let's see. Okay. So what I want to do is I want to start by removing so because I want to start by removing caps around the audio chip, which is U6201. So I'm gonna uh, let's see what C6306 is saying. Let's see that. Uh, let's remove that and take it from there. First, we remove the edge bundle. Okay, so what you want to do is, even though C6306 doesn't really look bad, I want us to take that out. Or we can remove L6201. Let's okay. Let's which is an inductor. Let's see what happens when we remove that cap. See what happens. In the same vein, we can as well remove L6201, then check what side is the short on. Because with an inductor, whatever you find on pin 1 of an inductor will be represented on the other side of the inductor. So whatever you find on pin 1, will you also find on pin 2. The inductor is out. Let's take the cap out. See, the cap will go out as well. Okay, our cap is out. So what I want to do is I want to measure the components, individual components, while they're out of the board. So I want to see on both. Okay, I'm just gonna let's see that. Let's see do we. Inductor is definitely going to beep. We are not worried about inductor. We're worried about the cap now. So let's measure the cap and see if the cap will beep. Okay, that's not our problem. Okay, fine. So that's not our problem. The cap is not our problem. But let's see what side the short is on the. Okay, that's fine. Okay, that is fine. So we don't have a short on. So we definitely did not have a short. We don't have a short by the audio chip. That's fine. So let's put back our component and move on. We may have to inject voltage We may have to use that method to find where the short is. Okay, so that is done. So what we want to do now is we may have to inject voltage on our board. The idea is that whatever component that it's creating the short will become warm enough that it can be felt. Sometimes it gets super hot, and other times it's just warm. So what we want to do is we will be injecting voltage into our board. We will give it a bit of time to cool off, otherwise um, that the idea obviously will be lost, because if the entire board is warm, you won't know exactly where the heat is coming from. So let's give it a bit of time for the board to cool down, because we did heat the board. And then we can basically run voltage through it, and then see what gets hot. That will give us an idea of where or what is shorted. Okay, let's now we need to attach wires to our board. Hello, hello. Walaikum salam. Go ahead. Okay, I'll try to inform her. I'm making the video at the moment. I'll try to inform her. Okay, let's now attach a wire to the SO line and see what gets warm. Okay, so what we want to do now is we want to gradually inject voltage on the SO line. The idea is whatever it's short into ground, power will start to obviously there will be power from that component to ground, and because the power is going to go through it, making its way to ground, you will have that component either getting really really hot or warm. So that is this can be pushed back a bit. Okay, so now uh, we'll have to gradually increase and then while we're doing that we have to be aware that we are the line is a 3 volt line, so we have to kind of try to work within that range of 3 volt, otherwise you may yeah. So let's just make sure the board is not warm before we start. I have fell off. Let's that again. Actually, we can just remove the cap. No, that's gonna hit the that's space out again. Okay, let's use a soldering iron to remove the cap. How interesting will it be that the cap is actually what is shorted? No, I don't think so. It's yeah, I don't think so. But you never know. So we can, out of curiosity, let's just check the cap. No, that's not. Our problem is not the cap. Okay, so the cap is out of the way. We just obviously we wanted room to connect our wire. Okay, so the next thing we want to do is we want to gradually, and while we are doing that, we will basically shift our focus to, you see where the pins are represented. That's where we will shift our focus to see what is shorted, and we are just hoping that we don't have an issue with the PCH, because we see the bunch of lines that go to the PCH. We're just hoping that we don't. So we just hope it's not the PCH. Uh, yeah, and we did check already at U6201, and we kind of settled that it's not the audio IC. So we see most of that is on this side of the board, and we are really hoping that we don't have a failed PCH. Okay, so now let's start, gradually increase voltage and see what gets warm. Okay, so now we can check, start to feel our board to see if anything is getting warm. We are really hoping that our we don't have our issue is not CPU related. That would be very comforting. So while we're doing this, let's take out the heatsink so we can also check our CPU. Mm, even though we're hoping that it's not CPU related. Hello, I'm okay. How are you? Okay, I'm actually in the middle of a stream. I will not be able to talk to you now. We should be done in about an hour from now. Thank you. Okay. This is not good. So our problem is actually the PCH. I'm not sure if you guys can see that. That it's not good. Uh, so we have a damaged PCH. I'm just gonna do this so you guys can see that. So that was our fear, and that's it. We have an issue with the PCH. Uh, so yeah, so that's it. Our problem is the PCH. Um, okay, so this board, so our short is definitely coming from the PCH. So this will need a CPU replacement completely. We need a CPU replacement for this one because of that. That's because I mean the PCH, the CPU and the PCH basically are on the same die, so we will need to replace this CPU. Okay, so that's going to be beyond the scope of this video because we don't have a stencil for this CPU. Okay, so another thing we can do, which is going to be like a quicker option, would be for us to find a donor board that doesn't have a failed CPU but has a different problem, and then we can fix that board in place of this board. Yeah, it's yeah. So that's most likely the quickest way out of this. But this board, it's the CPU is our problem. Uh, so I'm just gonna. Uh, okay. Yeah. Yeah. CPU. It's, okay. Okay, guys. Let's see what option we will come by for this client, and yeah. For now, I will see you guys in the next video. Thank you.